Welcome to this lecture. In this lecture we are going to make our own Nmap module with the help of these libraries. So first of all, you have to go to this website, that is nmap.org and /download.html, or simply you can search for Nmap for your machine. And after that, I'm on Windows, that means I'll just download this Windows binary. You can simply click on this installer, you will save this by downloading, and after that you just download that. You should open it and you should install on this drive, C drive, and you'll see that it is installed in program files, and here is Nmap. So next thing is to just copy the installation, the file location, and after that you have to go to your PC and go to the properties. After that, advanced system setting, environmental variables. Inside this path you have to just edit here, and in my case I have already put this Nmap location, but now you can simply click on new and you can just paste it over there. So now after just you apply all of this, you'll just go back here, and now we have successfully installed the Nmap. Next thing is to install this Python Nmap module. So you have to open your terminal and simply just copy from here, and I'll just go back to the terminal, paste it right here. After that you have to just install this Python Nmap. I've already installed, and now after closing this you are good to go with the coding. So before that, I'll just open my ideally and show you what we are just doing here. So in this lecture we have to make this Nmap module, and we'll just make a port scanner with the help of this Python Nmap module. So first of all you have to import that Nmap, that is Nmap, and now let's instantiate this Nmap, and let me say the scan is the object, and after that I'll say Nmap dot port scanner. So this is the important class, so it is a port scanner. If I just click OK, there is single pop-up screen, that means our port scanner is up and running now. So you can now scan the any IP field over here. So you have to first type the scan, and the method over here is the scan method. So in this scan method you have to give the host name. Here is IP address, so I'll simply give the localhost to give you a real quick example. After that you have to give the port number, so I'll just say 222443. let's check this port number, and here the arguments is optional, so I'll just left it here and I'll just hit enter. It is going to scan us and it will just come after a minute, so let's wait and let's see its result. It will take some time and give you result like this. So you can see you have the dictionary over here. The result is in the form of dictionary containing some of this information. You could see the host over here, you could see the version, you could see the name, you could see everything over here. You can see the services, you can see the method, which is obviously the syncing method. We'll see all of these in the next minute, but for now you can see this is scan info, which is TCP protocol over here, and now you can just reference each of these keys and values of this dictionary. So if you want, let me say command line, you can simply do something like this scan dot end command line. So if you see this, and if I hit enter, you are going to get the command line over here. And the next thing you can also do is you can also get the protocols, all of these protocols of this scan. So you can have something like the IP over here. So first of all it should be IP, which is obviously our local host, and if you scan and get all the protocols with this all protocol method, and if you just hit enter, you'll just get TCP over here, which is our protocol. If it has more protocol than TCP, it will just print out in the form of list. So next thing what you can also do is you can also see the state, if it is running or not. So we'll just say scan again, and localhost, which is obviously this host we are just scanning, and now I have to just see the state, if it is up and running or not. If I hit enter, it is saying up because it is running. So you can just check all of these states, and all of these key and value pair from this dictionary. So you can also check something like the host name. If you, let me just grab all of this, which is obviously our host, and if I just check for the host name with this hostname method, you will see it is localhost. So you can do multiple things from this Nmap port scanner, which is going to scan us with this host name, and this is the port to be just searched. And next one here will be the argument. So argument will be in the form of the characters, and you can just search in the Google, so something like this will appear. So these are all your arguments. So if you see SV over here, it is the probe. It is basically searching for the open port to determine the service version info. That means if we just go back to our ideally, this CSV argument refers to the open port because it is searching for the open port to determine the service and version info. So these are some arguments to be searched. So we'll make now our own Nmap scanner, and we'll see how we can just scan the IP addresses with the UDP, TCP, and the comprehensive scan. So let's open our PyCharm over here. Let's do real estate coding now. So first of all, we'll show something like the 3 type of scan we are going to just encounter over here. So first over here will be sync scan. Let me write the type of scanning first, and the next one would be your UDP scan, and the last one would be the comprehensive. So first of all, let's see about the sync scan, which is also known as the TCP scan. So this sync scan is the tactics. Basically, it is a way that the malicious hacker or a cracker will use to communicate with the victim's port without establishing a full connection. That means this scanning will just scan the port number, but it won't have any connection with the victim computer. This approach is the oldest approach basically which the crackers use, and it is also used to perform the denial of service attack. And the sync scanning is also known as the half open scanning, because in this case we are not connecting fully with the client computer. Instead we are just having a half open scanning attack over here. So next one would be your UDP scan. So it is also quite similar of that of sync scan, but in this case UDP is a connectionless protocol. That means there is no equivalent to this TCP sync packet. However, if the UDP packet is sent to the victim computer or open port, the system will respond with a port that is the unreachable message, and in that way the response will indicate that the port is open. And we have seen about this sync and UDP in the previous lecture, so that won't be problem for you. So it is basically a 2 type of scan. We'll see in the argument section how these scan differ from each other. So let's start coding here. So first of all, as always, we have to import the Nmap module. So this is the Nmap module. So let's make a scanner now. So first of all, we have to just instantiate this Nmap module. That means with this help of PortScanner, we have seen about this PortScanner in a minute before. So first of all, let me just give the message to the user saying welcome to our Nmap PortScanner. So this will be the message to the user. So next thing is, let me just make quite some spaces over here, and now after this what you need to do is you need to have IP address. So IP address should be input from the user. So you know how to input. It is going to give us the message to the user saying please enter the IP address you want to scan. Okay, this will be the message to the user. It will just input that IP address, and let's print this IP address again to the user saying the IP address is, you can simply format this with your IP address. So now what we done was we just see the IP address. So let's see the type of the IP address. So you know what this type method does. This is going to just return us the class. So next thing is to get the response. So what this response does is it will just take the input from the user to see what the user want. So if the user want to have the sync scanning, then it will just get to the sync scanning. So what this response does, it will have the flow control. That means we'll use the conditional statement to have the flow control between this scan. So if a user presses 1, then it will redirect to the sync scan. If he presses 2, it will redirect to the UDP scan. If he presses 3, then it will just redirect to the compressive scan. So that means there will be flow control. So in order to get that number entered, we'll just use input again. And if you remember, we have this triple quote to have the multiple line. So I'll just make a multiple line and a single line, new line over here, that is with the slash n, and I'll just say please enter the type of scan. Type of scan you want to perform. So we can just go down because this is a multi-line comment. So first of all, I'll just give one here saying if you want the sync acknowledge scan, and the second one will be UDP scan, and the third one here will be comprehensive. So this will be 3 scans, and if I just put a new line again, so this will be the response from the user, or basically to the user. So after that they will just get that number. I'll just print you have selected option, and that will be res, which is basically the number. So they will just get that number. Let's check now. So if res is, so if you just do 1, this is not going to work, because if you see this res is from this input method, and we have talked about this in a multiple times before in the basic Python lecture, that this input method is going to give us the string, and this 1 is basically an integer. So we cannot compare this input, which is in the form of a string, with this 1. So we have to just pass this as a string. So first of all, we just compare with the 1, and if it is the case, we have to now do something, that is your sync scanning. So let's do sync scanning. So first of all, let's check for the version of the Nmap. So I'll say Nmap version. Let's print this Nmap version first, and it will be done with this scanner, which you can see here, which is the object of this Nmap, and we'll make use of map version method over here. So it is Nmap version. So this method will be called to check the version of the Nmap that is installed on our machine. So next thing is to see that what this scan does. So we have seen this scan was going to give us the dictionary. So let's see how we can just get the dictionary. So first of all, first parameter that is to be sent in this scan is IP address, which is entered by the user here. So the next thing was the port range. So I want to check from 1 to 1224. The number of port to be scanned is till here, and the next one is the argument. So let's talk about this argument. So first of all, I'll see v, and the next one is yes. So what we did here was we just gave the argument to this scan, saying that it has to just scan with the verbosity, and SS is to scan for the sync, connect, acknowledge, Windows or minimum scans. If you want to know for further, then you can just check this documentation online in this book reference page. So if I just search for V, which is obviously our verbosity, so that should be right here. It is saying increase verbosity level, and you can also use VV for more greater effect. So this is your argument, which is we just pass right here, and this SS means that we want to just see the TCP sync scanning. So this is the way to put the argument to our scan method. So next thing what you need to do is to print that. So basically what we get from here is the dictionary. So I want to get the scan info from the dictionary, so I'll just say scanner.scan info. So this will be the method. So what this scan info does is it will just give the dictionary for the method like sync and services. So next thing what I want is the IP status. So let's print if that IP status is up or down. So for that we have to first of all type the scanner, and we have seen this in a minute before, because in that case if I just go to the ideally, I'll show you over here what we just did was in the case of this state. So we just pass here the localhost, we saw the state which was up, running or not. So we'll do same over here. So instead of localhost we have to pass IP address that is entered from the user, and now we have to see the state. So before that let me just print some messages over here. So I'll say IP status, and after that I'll just put here the status, which will be done with this state method. So we have now the state method which is going to give us the status either up or down. And the next thing I want to give here is our protocols, which will be TCP protocol. So if you just see in the ideal again, which was right over here, so let's make use of this method too. So I'll just say scanner, and let's put again that IP address inside that scanner, and let's check for all protocols. So this will be message, or basically calling the functions to get the TCP. And the next thing is to check for the open port, and this is important, we haven't done this before, so we will check for the open ports. So to do that we have again this scanner, and we'll just pass IP address that is entered from the user. Now in this case we have to make use of the TCP keys, because this is the TCP scanning. So we'll just pass TCP, and now we'll just get the keys, which is for the values. So what this result is, basically this will give, this last statement will give us the dictionary, and dictionary will be in the form of the port number. So we'll get number of ports that is open. So that can be something like the dictionary, which will be in the form of 123 or 55. Any port that is opened will be result from this statement. So this is our pretty much the first scanning, which is our TCP scan. So we have completed our TCP scan over here. Let's go to the elif part and type something like, if the response is greater than maybe 20, then print invalid, something message like this. Now let's check for our first scan. So first of all I'll just go to the run the main. So it is showing errors saying that resp is what we just did here. We have to check if it is 1 or not. So let's run this again, run the main. It is saying enter the IP address to scan. Let me make some spaces over here. So I'll make spaces. Let's stop it again. Let's go and run this main. So it is going to give us the IP address to scan. So let's see our IP address from here, IP config, then you'll just get the IP address 192.168.1.14. so I'll just type here 168.1.14, and it is the message that we just get here, which is saying input which scan we have. So in this case we have only the one, which is obviously the SCK scan, which is sync SCK scan. So that means I'll just put here 1. So I'll just enter 1 now, and it is giving us the selected option. So first thing that we just get was Nmap version, because if you see here we are just printing the Nmap version. So first thing we just get is Nmap version, and the next we get is this TCP. So this is in the form of the dictionary, which was the result of this scan info method, and it is giving us the method, which is obviously a sync method, which we just did here. It was a sync method, and the next was the services. So services was basically to scan the port from 1 to 1024, and next was to see the state, if it is up and running or not. So IP status is up, and the next one was the protocol. So protocol is TCP protocol, and the last one was the open ports. So these are the open ports, or basically these are the ports that are open on this machine. So you just get open port from this scanner. So in the next lecture we'll complete with this UDP scan and the comprehensive scan. So see you in the next one. So in the first lecture we just completed our sync SCK scan, which was result right here, which was giving the version, and the important thing over here was the open ports. So we just get the open port from our Python code. So let's do for our UDP scan now. So that will be in elif part. So I'll just say elif this response that is given from the user is 2, and you know that it should be 2, which should be the string, because we get the response is the input, which is obviously in the form of a string. So next thing I want to is scan, or basically print, is the version again. So I'll just copy it, paste it right here, and the next thing is to scan as always. So I'll just say scanner.scan. So if you just remember, this is the UDP scan. So first of all I'll just say IP address, and the next thing is to port. So port will be 12124, and the next one here would be the argument. So if you just remember, in the case of this SYN, we just did the verbose, and we did something like this, which was the case for this TCP scan, but this is now UDP scan. So first of all we'll do the verbose scan, and the next one is SU. So if you see, SU is for the UDP scan. So now next thing is to print again the scan info. So I'll just say scanner dot scan info is the method that is going to give us a dictionary again about the methods, and the next one is to print the IP status. So I'll just gather everything of it. So it will be same for protocols and for the IP state, if it is up and down. So I've got the TCP protocols. So in this case it will be the protocols, and the next thing I want to check is the open port. So now let me print again the open ports, and in this case I want to just use the scanner method again, and in this case it will be IP address. If you see, in the case of this SY scan we have done the same, but this was TCP. Now this second option is for UDP, so we have to put the UDP here and just get the keys, that is the number that we want to get from this port. That means we just get the open port from this UDP. So if I just run this again, so if I just run from here, then let me just grab this. So it is saying the IP address, so it would be same 9168.1.14, and now if I just press 2, then it is also going to have the UDP scan. Let it wait for a moment, it will do its tasks. It is only giving the Nmap version, so it is more bulkier, or it will take more time than the SYN, which is sync attack. So let it give a time to have this scanning process. So now we have successfully found the open port for this syncing or scanning process. So you can see the IP is up and running, and the method over here is UDP now. So this was next step, which was basically for our UDP scan. So the next one is the comprehensive scan. So let's do this, the last one, which is obviously our comprehensive, and the response would be, let me say, if the user press 3, then I'm going to get this comprehensive scan. So let's do something for this comprehensive scan, same as before, that is getting this print which is saying that this is the Nmap version, which will be obviously the 7.70. And next thing is I want the scanner to scan in that IP address that is entered by the user, and now it has to just scan every port from 1 to 1204. So basically this is the range. So every here we type at the second argument is the range of the port to be scanned, and the next one is the argument. So if you get any confusion about this port, you can simply Google saying that the argument for the Nmap scan. So you will get this document getting all of these detections argument. So you can see we have the host discovery arguments over here, we have the script scan arguments over here, OS detection scan over here. So we are going to use this OS detection now in this comprehensive scan. So let's do this. So first of all, as always, we'll just do the verbose scan. So next one would be yes attack, which is obviously to see for the TCP attack, or basically TCP SYN scanning process. And the next one I want is V, and it is yes and V. So this one is to check the port to determine the services and the version info of the machine. And the next one I want is C, and what this does is, let me just type real quick, C. Here C is the capital, and SC is equivalent to the script being the default. And let me type the another one which is very important, this A in the capital. This enables the OS detection, version detection, and script scanning. So basically we'll get the version and OS with this argument. And the next one I want is O for the OS detection. So if you want to just gain the more knowledge about this argument, you can simply search here. So if I see O, we have just added O over here, which is right here. So this O argument is saying that this is to enable the OS detection. So you can see Nmap has bunch of these arguments, but just remember, if you add more and more of these arguments to your programming, it will be more time consuming. This time scanning, or basically scanning process, will be more time consuming if you add more and more option. If you add something like, let me say, if you want to do this debugging level, or you increase the debugging level, then you can see simply add this small d, but I'm not going to do that because this will be perfectly for this comprehensive scan. So next thing I want to do here is same as before to check the scan info. So first of all, I'll use this scanner object again, and I want to get the scan info, which will give the dictionary about the methods. And the next one is to check for the IP status, same as before, and to check for the protocols. Let me just copy this and paste it over here. So this IP status is going to show us if the IP or if the machine is up or down, and this will give us the TCP protocol. And the next one is I want to check for the open ports. So let's do that. So here in this comprehensive scan, I want to do this TCP open port scan. So let me just copy this, paste it over here. So we have completed our lecture. So if user presses above 3, let me say if it is greater or equal to 4, then what we need to do is simply print invalid, please enter valid option. So this will be the result, or basically message to the user. Now we have completed our code here. So first of all, let me just run this real quick, and you'll just get this message saying enter the IP address you want to scan. Same as before, you can simply check your IP address by just going to the command terminal and just typing ipconfig, and you will see this is wireless LAN adapter having this IP address. So I have just copied over here, and now I want this comprehensive scan, which is at number 3. Let me just hit enter, and it will just do now the comprehensive scan. Let it give a time. It will take more time than these two scanning process. So SYN attack was so simple that it gave the result within the minute or less. UDP scan took about 1 minute. Now comprehensive will take maybe more than 1 minute. Let it give a time. I'll just pause and give you the result. So we get all of these open port now, and you can see we get the same result over here, which was done in the case of sync, but it is more comprehensive than that of sync scanning. So we made our Nmap scanner over here, which will get us the open port, the IP status, the scanner result, and all of this information that we just see over here. So you can also see the command line over there. So you can do this by your own way. So we just made our complete Nmap PortScanner using this Nmap module. So this will be wrap for this lecture. Welcome to this lecture. In this lecture we are going to make our own PortScanner with the help of our Scapy module. So before that, let me just open my terminal in the Kali Linux and show you about the NetDiscover. So if I say NetDiscover is the program, and let me just give the interface, which is obviously my interface WLAN 0, which is wireless network. If I hit enter, it is going to scan us and it is going to give us all of the IP addresses and MAC addresses of that devices that is connected to our network. So you can say these are the 3 devices that is connected, one being a router, which is obviously the gateway over here, and next one is the devices, that is the hardware that is connected to this network. So we are just making this program with the help of Python in our PyCharm module. So before that, just remember what we are just going to do. So first of all, you can see that we have this machine. So just remember this is our machine, and maybe this is the client. So you can see this is a mobile and this is the PC, that are the clients over here, and this is the server obviously, and the internet, maybe we have the router here, and this is maybe router, and this has its own IP and MAC address, because we have said here that every devices has its unique MAC address. So if I just go over here and show you that this devices, being the router, has its own MAC address, and this has its own, so every devices has its own MAC addresses which is unique from each other. So they are unique because every packet has to send to some of the devices so as to recognize that device. So if I say that I want to distinguish this device from this device, then it is not from IP address, this is done from the MAC address. So whenever the packet is sent from the router, then that time it is helped by this MAC addresses. So packet is sent in this MAC addresses rather than just showing the IP. That means MAC address is very important information together, because packet is sent with the MAC addresses. So there is 2 information that is related to the packet. So let me say this is the packet that is sent, then there will be the header and some of the information over here. So there will be source MAC address, that is the MAC address of the source which is going to send that packet, and another is a destination MAC address which is going to receive this packet. So this 2 is a very important information. So first of all, there is one protocol which is going to be our ARP protocol, which stands for Address Resolution Protocol. So just remember that we have the ARP protocol to deal with in this lecture. So before that, let me show you how this packet routing works in the internet. So first of all, what happens is this is the client, and if this client wants the information of other client that is connected in the internet, and if this wants to get the information of the client or the MAC address of the client, so let me say it is done by first the ARP request. So this client, being this client which is connected to the same internet that other client are connected, this will first give the ARP request. So it will just say ARP request sent to the router saying who has this IP address. So first of all, it will just send this IP address that is unique. Maybe this client will just give the ARP request in the form of the IP saying that who has this IP address, and this is sent over all of the client that is connected in the internet through the broadcast MAC address. So after that, if it broadcasts all of these ARP requests, then the client will have its own IP address. So this has own IP address and this client has its own IP address. So this IP address, or basically this request which is sent from this client, will be ignored by those client who doesn't have this IP address. So if this says something like, okay, who has this IP address 10.2.1. maybe 4, and if this is the IP address of this client, which is the computer, but not of this mobile, that means this message, which is ARP request, will be ignored by this client, and this client will just get the ARP response saying that I am this client which have this IP address back to this broadcast manager. And this will see that, okay, this client has the MAC address and this is the address resolution protocol. And the next thing is very important information over here is a MAC address, and MAC address is very important because this is not obviously the MAC that we are going to use, which is obviously the computer. So MAC address is a media access control address. So it is basically the hardware identification number that is uniquely identifying the each devices on the network. So I have shown you in our Kali Linux over here that each of these devices will have the unique MAC address, which is to identify between these devices. So if you send any packet from these devices, from one devices to another, this MAC address is going to be unique, so that that packet can be traced, or that packet will be identified, or the packet will be delivered to the right devices. So this is the important information, MAC address. So we'll just code this NetDiscover with the help of PyCharm now. So before that, let me just make you real quick what we are going to do. So first of all, we have to make the ARP request, and then we have to make a broadcaster. So in the broadcaster, what happens is we'll just send this ARP request saying that, okay, you need to send that ARP request to the broadcast MAC address, which will just determine which clients are connected to network, and we'll just get this information of the client that are connected to the network from this PortScanner module. So in this lecture, we are going to make a Scapy module. So let's get our PyCharm ready and let's see how we can just make our Scapy module on PortScanner. So first of all, let me just delete all of this. Let's go back to our PyCharm. So here, the first thing what you need to do is you have to just go to your project, create a new Python file. I have already created, named is main.py. So next thing, if you see here, we want to go to the settings, and under this your project keylog, which is the name of your project, go to the project interpreter and just add the Scapy module over here. So I'll just say Scapy and install that Scapy module, and I have already done over here. You can see right here we have the version of the Scapy over here. If I press OK, now we can get that Scapy module to work for us. So first of all, I'll just import that Scapy module all. So all is basically to implement every module of the Scapy. That means we can use everything that is declared inside that Scapy module over here. And I want to alias it with Scapy. So every time when I want to use that Scapy module, I don't need to write scapy.all. Instead, I can just refer it with Scapy. So now next thing I want to do is I want to make a function that is going to be the scanner function. I'll just pass here IP address that is to be scanned. So this is our function. So next thing is to use this Scapy, and I'll say rping. So this is the method that is going to spoof for us. So next thing what you need to do is we need to just make this scanner work with the IP address. So if we just go to the command prompt over here, and if I search for our IP, then it is connected over here. So the IP address is 192.168.1. So if I just go here and I'll just pass here 192.168.1. So first subnet in this IPU is going to be the gateway. So first of all, we want to have the gateway, and to include every subnet from 1, which is obviously this digit, to 254, we need to just put this #24. That is to include every subnet on this network, or basically on this IP address. So just pass this /24 to include every subnet of this IP address. So next thing what you need to do is simply go to the run this main, and give it a time to run. and it has begin the emission. Let's see how this works. So it has received the 3 packets and got 3 answers. So these answers are responses, and it has shown that remaining 253 packets were unanswered. That means we just got 3 answers. That means 3 devices are connected to this network. So you can see we got the same, that is MAC address and IP address that we just got from the Kali Linux over here, which was the NetDiscover. So what we just did in this lecture was we made our Scapy module to work for the scanner. We didn't do anything good over here because it was just a one-line code. We'll see under the hood how this works in the upcoming lecture. But for now, what we just did was we just passed the IP address or every subnet of that IP address that is connected over here, and we just get this RPing to work for us. So what we just did over here, so let me show you real quick. So first of all, we just did something like this was the client. So basically this is us, and we want to give the ARP request. So it is giving us the ARP request. So it is just giving us the ARP request of maybe 10. So it has the IP address over here. So let me go real quick. So if I show you here, then this is your IP address, that is 192.168. So it is just showing us over there. So if I just go back, and it is just giving a ARP request with that IP, which is 192.168, and that is 1, which is obviously the gateway, the first IP. And after that, it is just giving this everything as a ARP request to just broadcast manager or broadcast. So after that, it is giving this to the broadcast MAC address, and it is just referring to every client. That means this every client will be included inside this IP address. So they will also give the ARP response back to the devices. That means it will just capture the MAC addresses of each of these devices, which is just done in this lecture, which is right over here. So if you see in the PyCharm, you'll see that we just captured every MAC address and got the IP. Obviously IP is inside this subnet. So after that, we just get every MAC addresses, which is just sending us the ARP responses. So you can see we got 3 answers. So this is very important, just remember here we got 3 answers. So these are the responses and other are unanswered. So there is 253 packet that is unanswered. So that is very important. We just received 3 packets. That means we have just 3 connected devices to the network. So now in the next lecture, we'll make our own scanner with the help of the algorithm that we just learned here. So instead of just using this ARPing, we can see how broadcast work, how to just make the ARP request, how to just combine those broadcast and the ARP request and send to the network, so that they will just give us the answer responses back to us, so that we can just modify it and make our complete again this NetDiscover, but in more robust way. So see you in the next one. Welcome to this lecture. So in the previous lecture, we just tried to make this NetDiscover. So basically what we just did was we just made use of this Scapy module to do that. So in the Scapy module, we just made use of this simple method, which is ARPing method, which will just pretty much scan all of these clients and get the MAC addresses. But in this lecture, we are going to do this manually. So first of all, we have to just create the ARP request. We'll send it to the broadcast MAC addresses, and we'll just combine those packets and see the responses of the packet. So one thing what I want you to see here is this message over here showing that it has received two packets and got 2 answers. So that means there will be the responses like answers and unanswered. That means we can make use of these responses to list out these MAC addresses. So in this lecture, we are going to do pretty much that. So if you just see here, in this figure, what we have is this client. So this is us basically. So what we are going to do in this lecture is we are going to make a ARP request saying that who has this bunch of IP address which is inside this subnet list, which is obviously you can see what we just have over here. So this will be the IP that will be sent as a ARP request by this client. After that, we are going to give this to the broadcast MAC address. So instead of just giving this ARP request to clients directly, we are going to give this ARP request to MAC broadcast or a broadcast MAC address, because this is going to give this ARP request to everyone, and this ARP request will have the IP addresses of each of these clients, and that will just give us responses in the form of MAC address back to us. That means we'll just achieve IP addresses and MAC addresses of each of the client that is connected to this network. So let's do that. So first of all, as I already said, so first task will be to create the ARP request. So you can see now we have to modify this code over here. So first of all, let's see how we can just modify it and we can just make use of this code. So first of all, we have to make use of the scanner class, or basically scanner function. So next is to create the request. So I'll say it is request. Obviously it is ARP request. So in order to create this ARP request, it is done by this ARP class. So let's make use of this ARP class, and now this is all to create the request in the Python. So it is very much easy. So you just make use of this ARP class to create the request. So next thing you can see is I'll just print the summary first. So let's see the summary. So summary will give the brief information about this request. So let's run this main module and let's see what this works. So let it give a time. It will take some time. So it has shown that ARP who has none says that this IP address. So if I just open the CMD, which is going to be my command prompt to see my gateway, so you can see here this is a wireless LAN adapter and this is my IP address. So that means this ARP request was done from this IP address. So we have successfully created the ARP request. Now next thing what you need to see here is the broadcast. So broadcast is to send to the broadcast MAC address. So I've already shown you before the steps. So first of all, we'll just create the ARP request which we just created. So next is to send, or basically to get that broadcast MAC address, because that broadcast MAC address is going to send this ARP request to every client. So let's make that broadcast now. So first of all, let's go again to our editor, and here I'll just say broadcast. So in this broadcast, you have to create the broadcast from Scapy, and we have the Ether framework to do that. So this Ether framework will create the broadcast for us. So now next thing what you need to see here is to give the destination MAC address. So what we just learned from here in this figure is, first of all, as always, we'll create the ARP request and send that ARP request to broadcast MAC address. So here, in order to assign that broadcast MAC address, we have to learn about the arguments first. So let's see what are the arguments that is given by the Scapy module. So in order to see those lists of argument, we have to make use of this ls function, and I'll just say Scapy, we want the argument or the attribute of this Ether module. So that should be Ether. And now if I just run this, you'll see the list of attribute printed right over here. So let it give a time to run. So you can see we have here that is DST, SRC and a type argument. So you can see this DST is the destination MAC field, which is what we just need, because I've already said you that this ARP request which we just created over here should be sent to this destination MAC field, which is obviously the MAC address of the broadcast. So this is the MAC address of the broadcast. So first of all, we have to make use of this DST. So the way to do that is, first of all, you have to just use this broadcast and give that attribute that is DST, and in that DST you have to pass this MAC address, which is obviously your virtual MAC address. So it is given right here, that is the FF, that is 6 times. So let me just copy this and go back here and let me just paste it. So this is the way to just assign this broadcast MAC address. That means now we have created our request, which is the first part. So I'll just say here ARP request is created. So next one was broadcast MAC. So the next thing what you need to learn is to send this packet and this broadcast to the broadcast MAC address. So let's see how we can do that. So first of all, let me just remove this, because this is going to show us the some of the attribute that we just need, and we only need this DST MAC address because this source is us. So this is MAC address of my PC. That means we don't need this, we just want this broadcast MAC. So let me just remove this line of code right from here, or you can also comment this out, and after that we'll just see some of the information that is given by the broadcast. So let's see first. So how we can do that is we can just print the summary first. So if I say broadcast dot summary, so let's see the summary of the broadcast first. If I just run this main, and let me just make here, and it has given the information saying that this is the source MAC address, that is our MAC address, which has this IP address, and it is just sending the packet to this MAC address, which is obviously the broadcast MAC address. This MAC address is going to send this ARP request to every client that is connected to this network. So this is the one step that we just did here. We just made use of this ARP request, ARP class to create the request, and we just now made the broadcast MAC address to be just working on this situation. That means we have to now combine this request with this broadcast, and we have to send this over the network, which will be done in the next lecture. So before that, I want to make you clear about the some of these requests. So first, let me show, instead of the summary, I'll just clear this out, and I want to just make use of this show method to show you these layers. So I'll just say broadcast dot show again, and I'll just remove this, and if I just run this main again, then you will see that it will just give us some information, and these are the some information that we have here. And this is the ARP layer, and we have here Ethernet layer, which was done by this Scapy module. So this is the Ethernet layer. You can see the destination MAC address, which is the broadcast MAC address. This is source MAC address, and we have see this ARP packet over here. So you has seen here who has this, which is basically the way to show who has that IP addresses in the network. So next thing what you need to do is we have to combine this request and the broadcast, and we have to send this over the network. So to do that, we have to first combine these requests. So I'll just say request broadcast. I'll just give the name again. That is a combination of both this request and broadcast. So in order to just combine this, first of all we have to pass the broadcast, and we have the special this forward slash, which is basically to combine this request and the broadcast. So if you wonder what this is about, so if you see, this is not the division sign in the Scapy, because we are using this Scapy module, and in the Scapy this is the way to just combine these two packets. So we have created now whole single packet over here. So this is the way. So next thing what you can do here is we'll just again show this layer. So I'll just say show method again. So let me just run this, and you'll see the 3 layer now. It will have our REST request first. So this is ARP request that we saw in the previous lecture. This was the Ethernet that we just made for the broadcast MAC address, and the next one here is Ethernet ARP combined, which is for this request broadcast packet. So now we have to do something like we have to send this broadcast packet over the network. So that is the way to just send this packet over the network is by using the SRP method, which will be covered in the next lecture. We'll see how we can just get these MAC addresses to be printed and see the network that is connected to our internet or to the connection. So see you in the next one. So in the previous lecture, what we just did was we just made this ARP request. We made this broadcast map just to get this from this Ether framework, that is just denoting this is a virtual MAC address that will just get every packet to launch, or basically it will deliver every packet to the clients on that network. And we just combine those broadcast and request packet with this Scapy one function, which is this / which is going to just combine this packet, and we are just going to show over here, that is this layer. So if I just run this main, you will see each of these layer printed out here. So let me just wait a moment, and it is going to give us this Ethernet, everything about here. So it is ARP, and it is combination of Ethernet and ARP, which is this broadcast, which is combination of this broadcast and the request packet. So next thing, if you just remember what I have told before was in this demo, if I just make a quick revision, that we just made use of this ARPing to see that MAC address and the IP of the clients that is connected to the network. So let me just run this one more time, that is this demo, and you will see now that it will just get every of these clients that is connected to this network quite easily, which is basically using this ARPing method. So you can see here it has received the 3 packet, got 3 answer. That means we have this answered package and unanswered packets. So these are the 2 responses that we get while using this Scapy module. So that means you can also see here we have to now send this packet. So basically we have already created now the packet. Now we have to send this packet to the broadcast MAC address so that it will just get every ARP response from the client. So as to do that, we have to first use some method of the Scapy. So that means we'll just say response 1. So I'll say response 1 and response 2. So this response 1 is the answered, and the response 2 is unanswered part. So we have this method, important method of this Scapy module, that is SRP module or SRP method. So this SRP method is a class that is going to just get every information transferred or packet that is transferred to the client. So this is important method. So I have to now pass here this request broadcast, which is our packet that need to be sent. And next thing what we can do over here is the timeout. So we can just add this timeout attribute over here to just indicate that there should be timeout, maybe after maybe 1 second or maybe after 2 seconds. So it can be about 1 second. So for now I'll just put here 1 second. So what we just did over here was we just made use of this SRP method to send our request broadcast that we just made over here at the timeout of 1. So now let me just close this down. So we just get now answered and unanswered. So this first one is answered packet and second response is unanswered packet. So let's see now what we can do with this answered packet. So before that, you can see this was our ARP protocol. So let me just give the message right over here. So let me say this is our request, which is ARP request. And now if I just say something like summary, if I want the summary to be printed, so let me just print this first and let me show you what this summary looks like. So if I just run this, and it is main, so if I just run this, then you will see that it will just take more time now, and now it will say that ARP who has none says that this is your source. So this is your source IP, which is going to just send that ARP request to the destination MAC, or basically to the broadcast MAC address, which is your this MAC address, which is virtual MAC address. And if I have to check this machine, that is the IP address, then you could see this is our source and its MAC address is right printed over here. So next thing is who has none. So this none is basically your these IP addresses that you just pass here. We haven't stored anything to here. So if you just remember from the previous couple of lectures before, this DST was the destination MAC address. So we just saw how we can just get these references. So that was the process to list every argument that was with this ls method, and now we have to make use of this ARP class to just list all of these arguments that we have here. So let me just comment this out, because we don't want this summary, we want this Scapy ARP here. Let me run this main. You will see the list of an argument that is available for the ARP now. So you could see these are the list that is available. So if you see here, if you just get the printed this summary too, let me just run this one more time. You will see summary will be told over here, that is saying ARP, that is obviously this ARP request, who has none. So if you see here, this field is none, which is PDST field. So this is none, and this SRC field is for the MAC address, PSRC is for this IP address of the client. So for now we have to make use of this PDST, because this is none, that means we can now include as an IP to this field. So same as we have done in the case of broadcast, we just saw how this was the field for the destination MAC address, and we just assigned this virtual MAC address to this destination MAC address. Now it's time to do that for this ARP request. So to do that, we have the request, which is obviously this request, and if you see here, that argument or that field was PDST field. So this was the field which has this none. So I have to now include that this is PDST, and that should be IP. So you can do this way, or there is also the another way to do this, and let me show you. So the another way to do is inside this parenthesis. So simply type PDST, which is the field, and now just pass the IP that you just passed over here while calling this scanner method. So we have now completed this ARP request. Let me just comment this out, which is to print the summary, and let me just remove this, or basically let me also comment this out. So now we have created our own Scapy request, that is ARP request over here. We have now created this broadcast MAC address, which is for this virtual MAC address. Next was we just combine those packets, we send that packet with this SRP function with the timeout assigned as 1 seconds, and we get this response. So this first one response is answered response, and the next one is unanswered response. So now let's see how we can just navigate to this answered and unanswered request. So first of all, before doing that, let me tell you this response, which is answered and unanswered, that we saw in the case of the demo. If I show you the output when we just run this demo. So okay, we haven't run this, so let me just run this real quick, and this was the demo, and this was going to give us, that is the answered package and unanswered. So this remaining 253 packets were unanswered. That means we have to now see what these responses are. So basically these responses are stored in the form of list. So you can check the documentation of Scapy to see that in the documentation it has written that these responses, that is answered and unanswered, are in the form of list. So if you just remember what we learned in the list section, that lists are iterable, that means we can loop over the list. So let me loop now. So for element in this response 1, so we are going for the response 1, which is for the answered packets. So for every answered packet, let me just print this first, which is this element, and let's see how this works. So first of all, so the thing we want to run is main, obviously, and let's see if this works or not. So okay, the next time it works. So there was no any problem, got 3 answers. It is saying that 3 is connected, so there is 3 machines or client that is connected to this network. So you could see the clear code over here, that is we are getting the response from this SRP, and that is on the timeout 1. We are just sending this packet of request broadcast. Just remember that PDST was to show the IP address. This is important, and basically we made this ARP request packed with this broadcast map, and that is sent over the client, which is in fact in the form of the responses. So this is response 1, this is response 2, and based on that response we just loop, because these responses are answered and unanswered. So if you just go in the demo, you could clearly see it has shown that with the ARPing there is the two packets, that is answered and unanswered. So first one is answered, so we just loop on this answered, we just print this one, and we get the result. So you could see result right over here. It is giving us the result in the form of this list containing two part. So let me show you here. This contains two part. So this is one part, and the next part here is this part. So you can clearly see the next part is this long part. So if you check the documentation of Scapy, they have written that the first part, which we have seen right here, so you can see there is a two part that is containing one part over here. So you can just distinguish this with the comma. So there is comma in between them. So first part here is the input part, or basically this is the request part, and the next part over here is the response part. So this has the three clients that is connected to the network. So first one is obviously the gateway, second one is this client, and the third one having this IP address, and you can go over here to see the MAC address. So you can see this is the source that is having the MAC address. You can get this MAC address with this SWDST, that is for the MAC address. We have already seen this while we just make use of this escaping. So let me show you right over here. When we just see this ARP, so let me just list out again. So with the Scapy, and it should be ls, and let's go for this ARP. Let me just list out the things that is going to show us the argument that is denoting us about the MAC address and the IP address. So you could clearly see over here, this SWDST was okay, this SWSRC was for the MAC address, and PCRC was for this IP address, which can be also seen right here. So this is your MAC address. We have another, this is the IP address. So we just get some of this client that has just connected to us, or basically they have sent us the packet in the form of ARP response. We just get this response. So you can also see the unanswered part with this response 2. If you see, this is the response 2 which is unanswered. So let me just run this unanswered part over here. It will just take some time because it is much more than that of answered one. So there was a small answered one, they were quite of 3, but this you can clearly see there is 253 packets that is unanswered. Only 3 were answered, that means 3 clients were connected. 253 packets was dismissed, or basically this was not doing anything. This means this packet was not giving any ARP response, but these 3 clients gave ARP response. That means there are 3 clients, we got their MAC addresses, we got their IP addresses. So now let's see only the IP addresses and the MAC addresses from this response 1, because this is all the unnecessary information that we get from here. So let me just comment this out first, and if I just run this main again, you will see we have these responses in the form of this list. You can see this is the list, and this, or basically you can also see the tuple. So this is a tuple, and this tuple contains the request part and the response part. So we don't need this request part because this is unnecessary information. We just want this ARP response part because this has the critical information about the MAC addresses and IP addresses. So let's get this part of the list or a tuple. So you know the list or a tuple indexes start from 0th index. So here in, let me just, okay, where is this run? So this part, or basically before comma, is at 0th index, and after comma is at 1 index or first index. That means we can now get the first part of this element. So let's do that first. So we can do something like, okay, here I'll just say that in the element I want only the first part, not the 0th part, because 0th was the request. We don't want the request, and we have now only the response part. You can also do something like here, because these responses, I've already told you, these responses are also in the form of the tuple. That means we can also get only the request part from this 0th, because the 0th is the insert part. If you want the unanswered part, that will be at 1, but we want the insert part, that will be at 0, and we get the response, which is the insert response. We just loop on that and we get the insert, that is insert responses. If I just run this now, we'll just get the information that is much more available, or basically much more valuable than before. So you can see we have now information that is in the form of gibberish. So we have to now filter this. So in order to filter, what you can do is use the argument. So we have learned how to take the use of p, that is src, and the next one would be to print the MAC address. So it will be element 1, which is showing us that this is the response, and src is for the MAC address. So this psrc is for the IP address, and this is for MAC address. We'll just get this information. Let me just print this one more time. You will see now it will just run its code, and it will get us the IP address, it will get us the MAC addresses, IP address, MAC address. So let me format it here. After every print, or basically after every client, I want to print some spaces. So this much spaces will be enough. Let me just run this again. You will see now it will format, it will just give us the information that is much more efficient. So let us go over here. You can see there is 3 client. This is the gateway, this is the MAC address, this is the gateway, this is the MAC address, this is the gateway, and this is the MAC address that we just catch from these responses. So in this lecture, we just made a complete scanner using this Scapy. So first of all, we just made the ARP request. We bind it with the broadcast over here by using the Scapy /. We just send that to the broadcast MAC address, which is done by this SRP, which will send this packet to all of the client. We just get the response from the client, which is insert part. If you want to see the unanswered part, it will be at first index, and now we just loop around it. But in this case, the information that is valuable will be at the 0th, because we want the insert part, because the insert part will be connected clients. So we'll just get the insert part response, we'll just loop on that, we just get these IP addresses and MAC addresses, we just format it, and we'll just print this in the way that normal scanner will do. So this is the same scanner that will be something like we do in the case of a NetDiscover, which is the Kali Linux tools. We can also do the Nmap Scanner, which is the case which we just get the MAC addresses and IP addresses of the clients that is connected in the network using this program. So we just made a complete program which can work as a scanner. So this will be wrap for this lecture. See you in the next one.